Hey folks, I'm Nick, like Dan said. I'm the tech lead of the core Crossplane engineering team at Upbound. I've been working on Crossplane for about 2 years, since shortly after the founding members open sourced it. And today, I'm going to talk to you a little bit about how to sort of compose your own cloud in Crossplane. So how you as a platform operator, as an SRE, can sort of define your own APIs that suit your opinions that you can offer to your customers or users. It's a part of Crossplane that I'm super excited about. So, as you've heard from the great folks who've been on the call so far today, Kubernetes has sort of introduced some folks, popularized for many others, the sort of power of control planes. If you look at just sort of the cloud controller space at the moment, there's tools like Config Connector from Google, AWS controllers, Azure Service Operator, and of course, Crossplane. As I say, we've been doing this for 2 years. And we think exposing all of these sort of cloud primitives, or just any kind of API really, via sort of one control plane is super powerful. But one thing that we kind of noticed early on is that Kubernetes resources can sometimes mix concerns inside one API object even. So if you look at the quintessential sort of deployment service combo to sort of get an app running, you have a mix of things like what to run, so the image, its arguments, environment variables, things like that, and also sort of how to run it, so where it runs, what node it's on, what security constraints should apply to it, rollout strategy, things like that. And in some orgs, I'm sure those things are all down to like one person or one team of people sort of thing, and that's all relevant to the person sort of making that API call. But I would hazard to say that in some orgs, those will sort of be different things where different people have opinions or want to set sort of policies. You might have a platform team say, no, I have policies on where you can run this or how secure it should be and things like that. And others, app operators might want to just control, what's actually running. And of course, there's plenty of great tools like Gatekeeper to help with these policies, and even built in things like pod security policies and whatnot. But maybe you don't even want folks who are authoring a deployment to see these settings sort of thing. And it's a similar story for cloud custom resources. If you look at what I'm sharing at the moment, this is Crossplane's representation of an Azure Postgres server. And similar to what I just said with deployments, it's got some fields that seem to me more relevant to someone who's deploying an app that wants to use this database. So it's got things like, how much storage space does this database need? I don't think it's pictured here, but you might have like, is it SSD or not? Do I need a fast one or not? But then it's totally got things that I can imagine a platform team might want to control. It's got things like what firewall rules should be open, should SSL be turned on or not? If these are all in one API object, does that mean, and if those things are in fact in your org down to multiple different people, do they have to collaborate on their API calls, sort of pair program them? That sort of makes it feel to me like it defeats the purpose of sort of a self-service benefits of control planes. So Crossplane wants to enable those people to focus on what they're actually concerned with. And as I say, those personas, you could have security folks, there's many different people, the personas often overlap and are blurred, but we're going to focus mostly on sort of the folks deploying the apps versus the folks providing a platform to deploy the apps on. And the way that Crossplane does this for you, that helps with the separation of concern, is through a layer that we call composition, that we built on top of the Crossplane resource model, the XRM. Before I talk about exactly how composition works, I'll give you a little bit of background on sort of how we got there. There was a lot of trial and error on our part to land at this model. But some great prior art, and one place that I feel that Kubernetes does pretty well with this separation of concern is actually in the storage system, persistent volumes, persistent volume claims, and storage classes. At the low level, you've got these persistent volumes that just have all the nitty-gritty details that you need to actually sort of get the storage that you need. But then there is a layer that you can optionally use on top of that of claims and classes, volume claims, persistent volume claims, and storage classes. And I would say that those kind of divide up the details of, hey, I need some storage, into, hey, I am providing platform-centric kind of nitty-gritty details in a storage class, things like file system or replication, or just what cloud it runs on, where it actually runs. And then a really app-focused lens into that, which is the claim, which is just like, hey, I need this much storage, and I need it to be rewrite, or I need it to be read-only, or whatever. So Crossplane, when I joined the project 2 years ago, was heavily informed by this. So to give a bit of context, the equivalent to like a persistent volume in this analogy in Crossplane is what we call a managed resource, which is effectively anything, any external system that you can have a Crossplane provider for. Often clouds, but could be on-prem, could be we've got one for SQL, we've got one for Helm, etc. We have a sort of a Crossplane resource model, which is a superset of the KRM. Tries to be a little bit more opinionated than the KRM about how things work, so that we've got a lot of good consistency. And we have one of these for everything that we can imagine. So we've got RDS, VPC, Cloud Memory Store, again, like SQL databases, Helm charts, things like that. We think of these as high fidelity representations of the external APIs that they represent. And what that basically means is we just take the external API and we try to map it back to Crossplane as sort of granularly and accurately as possible, while still remaining inside the bounds of the XRM, which is of course a superset of the KRM. So when we sort of set out to solve this separation of concerns, we did the same thing originally that we saw with PVCs. We had a resource claim and a resource class built on top of these. The resource class was like a storage class. It just had all of the nitty-gritty details in it, all the things that a platform team might want to specify. And the resource claims turned out to have basically very little in them at all. So the resource claims in our model were initially generic sort of concepts like, hey, I would like a MySQL database, regardless of whether it's RDS or Cloud SQL or Azure SQL Server, or I'd like a Redis cluster or like a Kubernetes cluster. And so we sort of quickly, by which I mean within a couple of months, ran into a couple of problems with this approach. I think that these can sort of these problems can be boiled down to just Crossplane can't be opinionated about these abstractions. We as the Crossplane community can't tell you what is best for you as an API, as a platform operator. So one problem is there's not always a clean one-to-one mapping between this sort of generic claim concept as one resource and one underlying resource that backs that. A great example is an Azure Postgres server. Azure makes a clever decision to be secure by default for a lot of their resources. So if you just ask for a Postgres server, you can't actually reach it from the outside world. You have to go and also create some firewall rules. And our original model didn't support that. We would just give you the server ability. Figuring out firewall rules is a separate thing, which really weakens that concern. But the big one is, how do you even write the schema for a MySQL instance that is all things to all people? Like, how do we define, here's what a MySQL instance looks like, and it will work and be useful to app developers on any cloud, any on-prem, any situation. So one option, which is effectively what we did, was we just sort of said, okay, let's take the union of things that are available on all providers that we support at the moment, sort of thing, on all clouds that we support, which turned out, I think, for us to be like engine version or something. So you, as an app developer, you could just say, hey, give me a 5.7 MySQL, and everything else was in the storage class and up to the platform operator. Another option that I think we may have considered, but to me it kind of seems like the comedy option now, is you take every possible setting from every possible cloud and put them all in this user-facing thing, which means, hey, if you're on GCP trying to spin up a Cloud SQL instance, first you've got to figure out which of these fields even applies before you figure out which of those is relevant to you. So we realized pretty quickly, as I say, that sort of the simple claim and class model unfortunately wouldn't cut it for something as sort of flexible and powerful as, orchestrating the entire cloud. And the platform operators really wanted to take control of their platform and define their own abstractions to offer to their customers, sort of thing. So, maybe that looks like this for your Postgres instance in this case. Maybe you want to just let your app developers pick the storage size and put everything else in sort of a class of service that you control, that they can sort of pick from. I think in this case, we've got the match labels there, which is picking sort of the GCP class of service here, the GCP composition. Or maybe you want something a little bit more like this. This is, you can see the API version. This is for Upbound. The other one was for Acmeco. This one, we give a little bit more flexibility to the app developers. We say you get that storage, but you also can pick what engine you're running, what version of that engine, a little bit of some firewall rules or allowed IPs, and a backup schedule. So just, two different takes on the same API that you might want to present to your customers to manage sort of their cloud infrastructure. So unfortunately, the only way to do this up until now really has been to roll your own. And Kubernetes gives you a great platform to start doing that. I would recommend if you are going to roll your own, then starting on Kubernetes is a really good way to do that. But it's still a huge investment. It takes a long time to get it done, to build your own opinionated platform on top of Kubernetes, to write that Go code, to write your controllers. It's hard to hire for folks. Trust me, I know, because we try and do it in my team all the time. It's hard to hire for folks who can do that. And even when you do, folks underestimate how hard it is to do. I've been an SRE for 10 years before I started working on Crossplane, and I've been at a number of startups that tried to do exactly this. And I remember walking in the door and talking to the engineering team, and they said, "We'll have this platform built in 3 months," and a year later, it's not done. So with Crossplane, we wanted to sort of help you do this. We want to sort of kind of in the build versus buy trade-off, we want to sort of let you have your cake and eat it too. We want you to be able to sort of choose Crossplane, but put your own opinions on the API that you present to give your folks a control plane. So composition in Crossplane is how you can teach Crossplane a new declarative API, and how to satisfy API calls to that API by composing one or more managed resources. So for taking those fundamental composable resources from Crossplane and building them up into a higher level concept. So the way that you do this in Crossplane is you start by defining a composite resource, which we call an XR for short, because Kubernetes stole CR. You do this by writing an XRD, which anyone who's seen the YAML of a CRD will see that this is quite familiar. We do have a few opinions on here. We try to take off some of the pointy edges, some settings that just aren't relevant to Crossplane. And we also inject a bit of machinery around composition. So there's some fields that line up on your XR that you didn't explicitly ask for. And one novel thing about this is getting back to that whole claims concept is an XRD actually defines 2 resources, a composite resource and a composite resource claim, which I'll touch on a little bit later. So the next step here is to write what we call a composition. Composition describes what Crossplane should do when one of your users creates a composite resource. So when one of your users is like, "Hey, give me a Postgres server, please," or "Give me a Postgres instance," like what should Crossplane do about that? So it's a YAML custom resource in and of itself, and primarily it contains an array of what we call bases, the bases of resources, and then each base can have 0 or more patches from the composite resource over the top of that base. So for instance, in this case, let me see here, this is a simple composition that basically will say, okay, we take a Postgres instance, and when someone asks for one of those, we're going to give them a Cloud SQL instance. And all of the settings that you can see there under for provider, database version, all that good stuff are just fixed in this base. But under patches at the bottom, we'll say take parameters.storage gigabytes from that Postgres instance, and just copy that over the top of for provider.settings.data disk size sort of thing. So that effectively allows you to sort of abstract this behind your API. Another interesting thing is that you can have multiple compositions that satisfy an XR. So that sort of acts as multiple classes of service. You could have, the Google one or the Azure one, or you could have, the very secure one and the sort of secure one sort of thing, or the big one and the small one. Compositions, as I mentioned, I think it can have more than one resources that they spit out. So I believe in this example, this is solving that Azure case that I spoke about before, where it's actually going to go create you an Azure database and a bunch of firewall rules for it. So in order to enable that, another thing that we have on top of patches is what we call transform functions, which are just simple things, simple things like change gigabytes to megabytes or something like that to allow you to write a portable abstraction. So if you have, say, Google wants storage in gigabytes, Azure wants storage in megabytes or something like that, you can just have it in one or the other in your composite resource and translate it. This is limited by design. There's no curly braces templates. Whoops, sorry. There's no curly braces templates. There's no loops, there's no conditionals. And while a lot of people fail at keeping their languages simple, we're hopeful that we will be able to do this because we have an escape clause, which is we'll just let you write real code if this doesn't work for you. So rather than having to accept any feature request for increased complexity here, you can just use that escape clause and write code to do this. So just to finish up, here's a little diagram of how all this fits together. And this demonstrates what I mentioned before, that we have claims as well as composite resources here. So claims are a app-focused lens into a composite resource. Composite resources all live up at the cluster scope. They're all sort of the platform operator's view into these things, which allows us to do things like say, okay, these two composite resources actually have a claim in different namespaces. They belong to different teams, but they both relate to a VPC, for example, that maybe doesn't have a claim because you don't want your users to be asking for their own VPCs, and you want to be able to relate those things together without violating namespace boundaries in Kubernetes. All right, that was just a quick run through. Thank you very much for coming and hearing about it. You'll see a bunch more talks about composition today. I know Jared in particular is going to give you sort of a more practical example of how you can use it. If you haven't tried it already, please, jump on our docs website and give it a run through, give us some feedback. I'll be on Slack to answer any questions right after this. Come get involved in the community. The community has given us a ton of requests for features, and my team doesn't have the bandwidth to build them all out. So I'd love to support you in building them all out. And if you're super passionate about this, come and talk to me about working on my team. We're hiring and we need many more people to help build this out. Thank you very much. Have a great day.